Hello, I'm Hao-Yu, and I'm presenting FROSS, faster than real-time online 3D semantic scene graph generation from RGB-D images. FROSS is a framework for generating 3D semantic scene graphs incrementally in real time. It achieves real-time performance by abstracting objects as 3D Gaussians instead of more common representations such as point clouds. More demonstrations of FROSS can be found in our project page. First, let's briefly define what a 3D semantic scene graph is. It's an abstraction of a 3D scene that represents objects as nodes and their interrelationships as edges. 3D SSGs enable high-level understanding of complex 3D environments and are particularly useful for applications such as robotics, augmented reality, and scene analysis. However, many of these applications require incremental and real-time generation, something that most existing methods cannot achieve efficiently. In this research, we introduced FROSS, a methodology for online and real-time generation of 3D SSGs with superior performance and processing speed. We propose an efficient merging algorithm based on 3D Gaussians for object integration, preventing duplication as the input image sequence grows. Additionally, we developed a new dataset, replica SSG, which extends the replica dataset by adding relationship annotations. This new dataset offers high-quality reconstructions of indoor environment for evaluating 3D SSG performance. A key insight behind generating 3D SSGs is that approximating objects, shapes, and locations are sufficient for maintaining meaningful scene graphs. Therefore, FROSS leverages Gaussian distribution to represent objects, enabling fast and incremental updates. In our pipeline, a 2D scene graph is first generated from the current image frame. Next, the bounding boxes of detected objects are converted into 2D Gaussians and lifted into 3D space to form a local SSG for that time step. In this illustration, previously detected objects are shown in green, while newly detected objects in the current image are displayed in their respective colors. Finally, these new objects are merged with previously detected ones into a global SSG by combining Gaussians that share the same semantic class and have a Hillinger distance below a threshold. The Hillinger distance intuitively measures the similarity between two probability distributions. By merging new objects at each time step, FROSS can build a 3D semantic scene graph incrementally and efficiently. Compared to prior methods, FROSS achieves significantly higher recall performance while maintaining much lower computational latency, which is 27 and 44 times faster than the two top-performing baselines. Qualitatively, FROSS can accurately approximate object locations and spatial extents. Furthermore, by leveraging richer information from the entire input image, FROSS better distinguishes between objects with similar geometry and semantically close relationships, for example, curtains and doors, or sofas and tables. In conclusion, FROSS is a framework for real-time generation of 3D semantic scene graphs in online environments. It achieves computational efficiency that exceeds real-time requirements by representing objects as 3D Gaussians. Experimental evaluations on both existing benchmark and our newly proposed replica SSG dataset show that FROSS outperforms existing methods in both recall and computational speed by significant margins. If you are interested, please check out our project page and code implementation for more details. Thank you.